I'm going to talk about whether open science is actually better science. And I think that's an interesting question, really, because I realized that day-to-day is really going to focus just on open science. And I felt like there are maybe a couple of things that I would like to talk about that we're not going to talk about much in detail today. And so I'm going to give you a brief overview of those things that I think make our science sort of more reproducible and more robust. But let's start with the question what open science actually is. And I guess open science means lots of different things to many different people. I personally like this sort of overview, although I guess it's probably incomplete. Where's my pointer gone? It's here. And the kind of things that we're probably going to focus on today is really open data, open methods, and open access, although I feel like open access is one of those problems that we've actually solved, so it feels like that's not something that we need to talk about very much nowadays. Why do we care about open science in the first place? And I guess, again, lots of people have lots of different reasons for caring about this. I guess from an individual researcher perspective, it's partly about, you increase your chances of collaborations, and you can even get citations for things like open data and open methods, for example. And it makes it a lot easier if you share your data and your methods in the first place to get people interested in your research. Then from a funder's perspective, I guess things like reuse of data sets especially will sort of increase the impact of the research that they fund, so that's why they are interested in these things. And also, I guess nowadays the issues around transparency and accountability are very important, and this is sort of where my interest comes from, and that's really around validation. And I think open science is one of the answers to what we nowadays call the reproducibility crisis, and I guess most of you are aware of what this is about. So I guess in psychology, there's this relatively famous paper that showed only 1/3 to 1/2 of the original findings were replicated in their large-scale replication study. And I think that, we can talk about terminology later, but I guess it's more about replication than actual reproducibility, but that's a different question. And then but it's not just psychology. We know from lots of different fields that we have problems with really replicating our research results. Same goes for social sciences. And also this is a paper from the preclinical world where in a pharma company, and I think this is from Bayer, they tried to replicate findings from the academic literature, and only like 30% of the cases they actually managed to replicate the findings. So from my point of view, I think the problem is that we have a lot of very unreliable literature. I think the quality of the research that we produce is just not high enough. And why should we care? Well, I think one of the reasons why we should care probably is ethics. So if you're working in a preclinical lab, you're probably wasting quite a lot of animal lives on research that's just not reproducible. In sort of the area where I work in, which is more clinical research, you waste your patients' time because if you put them in a clinical trial that's never going to produce useful results, then they can't go into a second trial that might be more robust. And then, finally, and this is one of the reasons why the funders are so interested in this, we're obviously wasting a lot of money on research that simply can't be reproduced. And I think it doesn't matter whether the figure is 85% or 50%. I think it's definitely too high when we look at the literature. And I guess we all have sort of an idea of how much we trust the literature. And I think sort of 85%, at least in my case, is probably sort of right. So in that case, I would say, I trust maybe 15% of the literature, but certainly not more. But I think also from a sort of higher level perspective, trust in evidence is, is obviously such a huge topic nowadays. And, we have a guy in the White House who doesn't, really care about medical research, who doesn't care about climate research, and, who basically says it's all, crap, what we're producing. And I think in some ways, actually, we have to find a way to argue against that. And I think it's really hard to argue against that if we actually believe that most of the science that we produce is crap too. So we need to have good ways of sort of rebutting these issues. But I think the main point really to make is that this is about ourselves. It's really hard to email your past self and ask yourself, what did I do 6 months ago? How did I really do this? And I think it's really important that working reproducibly is actually, from a very selfish perspective, very useful. So in 6 months' time, in 6 years' time, you will want to understand exactly what kind of analysis you did. You might want to use the same analysis pipeline on a new data set. And if you don't work reproducibly, that's actually going to be very hard. And it's going to cost you a lot of time and effort to sort of try and reproduce your own stuff. So I think really from a selfish point of view, and again, I think we'll talk about this later today as well, it's very important to think about how we can make our research as reproducible as possible. And how do we do this? And I guess, like I said, open science is part of the picture, but I think it's actually a much bigger picture than that. And I'm going to focus more on sort of good research practice and what we need to do across the sort of research cycle to improve the way we do research. And I think it really starts by asking the right question. And one of the issues that I think we have nowadays is that most of us don't really do very good literature reviews. So we tend to do narrative reviews. We tend to pick the sort of 1 or 2 or 10 papers that sort of support our hypothesis. But I think it's really important to do a systematic review in the sense that you need to get an idea of what the literature actually is about and try and find every individual paper rather than just the ones that support your hypothesis. And try and find out sort of where are the gaps and what kind of follow-up questions should I be asking. But then also I think we need to work towards a system where we are much more collaborative, where we talk to our colleagues, we speak to clinicians, and I think nowadays I think it's a lot easier to actually talk to patients and the public directly. And this is something that's, I guess most people are aware of PPI, patient and public involvement, which is something that's pushed by the James Lind Alliance. But also I think things like social media and citizen science projects make it a lot easier nowadays to interact with the public and try and understand what drives them and what are kind of research questions that they would be happy to support, for example. And I think that's a very, very valid question because in the end, we are mostly funded by the taxpayers' money. So I think maybe we should ask them what they think we should be interested in as well. And like I said, just sort of be open and collaborate, even at the stage of developing your own hypotheses. I think that's sort of the system that we should work towards. The thing that I'm going to spend most time on is really experimental design, because I think this is where we can improve the most, really. And I think the first question should be for pretty much everyone: do you actually need to collect new data sets? So there's Google has recently launched their Google dataset search, and I actually have no idea how well it works. I haven't tried it yet, but I think it's an important question. How much data is actually out there? And do you need to collect new data in the first place? Are there other data sets that you can combine your data set with? And I think we're going to hear about this later today as well. And when you're designing your study, I find it actually really interesting to look at reporting guidelines. And there are lots of reporting guidelines. The Equator Network, here, this website, has a very nice overview of lots of different reporting guidelines. This one is for neuroimaging, but that sort of the reporting guideline already gives you an idea of what's really important in your study design. What are the questions that you should be looking at? And I guess when it comes to study design, there's these sort of eternal questions. How do you deal with bias? How do you deal with confounders? And how do you deal with chance? And really chance is something that I want to spend a bit more time on. So statistical power is, I guess, something that we recognize is a problem in most of our studies. And this is a very nice sort of overview from Kate Button's team, where they looked at statistical power in neuroscience. And we know that from this paper that the median statistical power in neuroscience is somewhere around 20%. In animal studies, it might even be up to 30%. Whoa, very exciting. In neuroimaging, it's somewhere around 8%. And that's really, I always feel like this is actually a disgrace. The problem is that the chance of finding a false negative is 1 minus power. So in neuroimaging, that's somewhere around 90%. And also the problem is that if you find a significant effect, the likelihood that this is actually not a false positive but a true positive is relatively small as well. And I think this is a concept that's unfortunately not taught very well in our stats classes, but I think it's a very important one, and it's one that we need to focus on much more. And just to give you a very brief illustration of this, when you think about, have you like an example sample size calculation with these sort of with these parameters, and you just want to do a one sample, one tail t-test, you need something like 36 participants. If you have 2 groups, and this is the kind of stuff that I normally do, so I try to look for differences between groups, you need something like at least 86 participants per group. And so the sort of rule of thumb that we have in neuroimaging that we maybe need like 20 per group really doesn't hold. It only holds if you're looking for very big effects. But I think over the years we've seen that actually the effect sizes that we're looking for are probably much smaller than we think. So I think this is just an important issue to try and remember. And I tend to tell people that if I want them to take one thing away from my talk, it's really to try and pre-register as much as you can. I think I realize that not everyone can pre-register every single study, but I think try and pre-register as much as you possibly can. And what is pre-registration about? Basically, it means that you write up your hypothesis, and basically you write up your introduction and methods section to the paper that you would write eventually, before you even start collecting your data. So you can then pre-register your sort of intro and methods section online, or use a sort of publication format that's called registered reports. And I'm not sure how many people are aware of what this is about. Basically, as a registered report, you send in your intro and methods section, again, before you collect the data, to the journal that you want to publish it in. And then it's going to be peer-reviewed. And it's going to be peer-reviewed purely based on the scientific merit, A, on the question that you're asking, and B, on whether you're using the right sort of experimental design to answer that kind of question. And it's going to be published completely irrespective of the results. And I think this is probably what we should work towards when it comes to our own research, right? We should publish irrespective of whether or not we get a positive or significant result somewhere. And the great thing about registered reports is really you get feedback before you collect the data, and you can put them on your CV before you have even finished the study. And I think this is a very important thing to keep in mind for early career researchers especially. You could put this study on your publication list, saying, as soon as I collect the data, as soon as I've finished analyzing the data, it's going to be published if I analyze it in the way that I sort of proposed to do it in the first place. And I put some links in here as well on if you want to look these things up. And I think pre-registration really gets around a lot of issues that we have around the research cycle. So it gets around low statistical power, because you have to have a certain statistical power to be able to use a registered report, for example. It gets around p-hacking, because you have to pre-specify in advance what kind of analyses you're going to do. So you're not really tempted to do like hundreds of analyses and just report the one or two that gave you a significant result. It gets around harking, so that's hypothesizing after the results are known. Because basically, you've stated your hypothesis in advance, and you're not going to change your hypothesis based on the results that you get. And it also gets around publication bias. And publication bias is the problem that we mostly publish significant and positive findings nowadays, whereas sort of the null results end up in our drawer somewhere. And in a system where actually your paper is assessed based on the intro and methods section and not on the results, you're going to publish probably lots more null results. And why is pre-registration so important? I think especially in the neuroimaging world, I guess many of you will be familiar with this paper from Ross Poldrak and others, where they looked at the sort of different workflows that you can get to depending on the sort of pre-processing pipeline you use for your neuroimaging data. And the important thing is down here, this figure, like 70,000. So you can have something like 70,000 different workflows. And obviously, that really invites you to do p-hacking, because if you can use different workflows and you can find good justification for using different workflows, eventually you will find some significant effect somewhere. And I think this is really where pre-registration helps a lot. And I can just say from my own experience that I think it's helped me a lot also in terms of thinking about your project really in advance and what are you actually looking for and what kind of factors are important. Right, now let's get to data collection and data analysis. I guess one of the first questions is whether you actually need a new method. And there's really great collections of protocols nowadays where people publish their experimental setups, for example. So I think the question is, do you need to invent something new? Do you need to reinvent the wheel? Or is there someone else who's already done that, so that you can also potentially compare your new way of collecting data with what they found? And then one of the things, again, that I think we don't focus enough on is sort of validity and reliability of our measures. So do I get the right answer, but also do I manage to get the sort of right answer more than once? And this is sort of a nice illustration of this. Basically, the situation that we want to have is we want to be in the bullseye, and we want to be reliably in the bullseye. So you could have a measure that's reliable but not valid, which might be, for example, a scales that's always 5 kilograms off. In that case, you would always get the same sort of weight for someone. So you get a reliable measure, but you get something that's consistently wrong. And in the same way, you can get a measure that's valid but not reliable in that, if you take an average, it's probably sort of the right answer. But actually what you want is you want something that's more reliably giving you the right answer. And again, when it comes to your measures, so can you compare them with a sort of gold standard, or is there a well-established test that you can compare them with? Can you do, and another issue that I think we're not worrying enough about, really, is do we do any quality control of our tools. So, and that goes for experimental setups, but that's also true for our acquired data. And how well do we do any quality control, actually? And then sort of how reproducible are our analysis pipelines. And I guess most of us write our own software in some ways, but many of us won't be software engineers, so we haven't really studied this. And I always say, well, I try to use as many sort of established pipelines from other people, because I think there's lots of other people, at least in my department, who are much better at programming than I am. So I think that really helps, because again, I don't feel like I need to reinvent wheels constantly. And then follow good programming practice, and I think an important thing to think about maybe for your project is whether you might want to test your code using simulations. So you can simulate your data set, and then basically try and find out whether you get the right answer by running your code on that data. And it's always, I think, really important to note that I think in science there shouldn't be any miracles, or there should be as sort of few miracles as possible, if you like. So think about reproducible workflows, and I'm not going to go into much detail on that because we'll hear more about this later today, I think. So these are different software packages that help you to make your workflows more reproducible. And then also think about good statistical practice. And again, we could probably spend hours and hours on this, but it's just one of the things that I want to flag up. What are we using the right stats for the kind of question that we're looking at, and also for the kind of data that we have. And then when it comes to interpreting and sort of publishing your results, I'm a big fan of open reporting, and I always feel like open reporting is missing on this sort of list of open science things to do. So open reporting to me really is about, on the one hand, publishing all the analysis you did. So publish the pre-registered analyses, but also your exploratory analysis. And one of the misconceptions about pre-registration is that most people say, yeah, but then I can't explore my data set. And I always say, well, you can explore your data set to the death, that nobody's going to keep you from doing that. But I think the important point is that really when you publish, you make a distinction between hypothesis testing. This was my hypothesis. This is what I pre-registered, and this is what I found. And then you have your exploratory part, where you say, well, in addition to that, I did lots of other interesting analyses, and here's what I found, and I'm going to basically follow this up with a second, probably pre-registered analysis. And then, very importantly, obviously, that we publish all our results, and not just the positive ones. We need to get to a situation where we have more null results and more negative results in the literature, really, and publish according to the best practice guidelines that I've just mentioned. And think about using preprints. And for those of you who are not really aware of what preprints are about, so preprints basically means that you have the finished version of your manuscript, the sort of final PDF version, and at the same time as you send this out for peer review, you can also publish this on a preprint server, and these are just sort of 3 examples of preprint servers that you can use. And so basically they are sort of available for the world to read before they've undergone peer review. And why are they useful? Well, they're useful because, as early career researchers, you can put them on your publication list to be able to show that, well, actually, A, I've done the experiment, but B, I'm relatively good at writing it up. So at least I managed to just sort of finish a manuscript, even though it's not undergone peer review. And I think the nice thing nowadays about the funders is that places like MRC and Wellcome Trust, they actually allow you to put preprints on your publication list, and they sort of count these as publications as well. So it's not like not like you apply for funding and you haven't got a peer-reviewed manuscript, so you basically you have nothing in your publication list. But with preprints, you can show that you've actually already done the work. And then sort of publishing open access is something that I'm really not going to cover because I think that really goes without saying nowadays. I don't know if anyone wants to have a discussion around why we shouldn't publish open access. I think it's basically, I can't find any justifications for that, but we can have a discussion around that later if you want. And then publishing data and materials, I think we'll hear lots more about later today, so I'm not going to cover this. So for me, really, the question to how we make our research more robust is on the one hand about open science or open research. So yes, open data, open materials, and open reporting are important. But I think good research practice also comes into play, and this is something that maybe we don't tend to think about enough in the sort of open science space, if that makes sense. So this is basically just in here to remind me, A, to take a breath, and let you take a breath, because I realize that this is sort of a long list for individual researchers. And I think the point that I'm going to make in the sort of the second part of my talk, is that really we can't do it all by ourselves. And this is, I tend to apologize for becoming political, but I think I shouldn't, because I think this is a very important part of what I think we should be doing. So I think we do need to change the system, and there's lots of different players in the scientific ecosystem. And I think as researchers, we probably have a duty to lobby our institutions, to lobby places like professional societies, and also the funders, to think about how the system needs to change so that we produce more reliable research. And yeah, like I said, I'm going to become a bit more political. And I'm going to tell you about what we're doing in Oxford. And I'd actually be really keen to hear what you're doing here as well. So I think this sort of exchange of information and experience is really, really valuable. So we started our initiative last year after Reproducibility Day, where we basically talked about all the issues that we have in sort of our with the quality of our research that we produce. And afterwards we said, well, actually we don't want to talk about these issues anymore. We want to think about what we can actually do to improve our own practice, but also to think about what we need, how the system needs to change. So we have mostly early career researchers from lots of different disciplines. And I think this list of disciplines actually shows you that this is not an issue that's inherent just in experimental psychology or even just in biomedical sciences. We have people from social sciences as well. And I think it's really important to note that you can look for people who might want to help you out on that sort of mission in lots of different departments that you didn't even think about. And sort of our list of demands, unicorns, rainbows, puppies, that came out of a Twitter discussion actually. But I think this is just to sort of remind people that I think what I'm proposing is really not that we antagonize people. I think it's very important to keep this conversation really positive. This is about making our life easier as researchers, and I think it's really about improving the quality of the research that we produce, and try to take everyone along as much as we can. Because if we antagonize people, we're never going to get there. So what are the kind of things that we're doing? We are organizing lots of different things. We have a journal club in experimental psychology. We have a seminar series. We have software and data carpentry workshops. One of the things that I was very heavily involved in was organizing the Berlin-Oxford Summer School on Open and Reproducible Research, which we ran in Berlin this September. And next year, we've just applied for funding to run it in Oxford next year. And next year, it's not just going to be on biomedical sciences, but also for social sciences. Because like I said, I think it's really fascinating to see that we have similar issues. And I think we have very similar solutions too. So I think teaching everyone about these is a very exciting project. But we also do things like providing speakers for lab meetings. I think that's been very helpful because there you have a sort of relatively small group of people where you can have a relatively intimate discussion around the problems that people face in their own labs. And then we're also in touch with several people to think about developing skills training around the issues that I've talked about for doctoral training centers and for MSc programs, and maybe even change undergrad teaching. That's going to be the hardest part, but I think it's one of the parts that needs doing as well. And so what are the kind of issues that we think we need to teach people more? I think it starts with the ethics of reproducible research. And I think that the interesting issue about ethics is also around ethics of open data, for example. There's lots of ethical issues, and when we look at our ethics review procedures nowadays, I think our ethics review is really not fit for purpose for the 21st century. So I think there's lots of issues that we need to solve there, and really teaching people about ethics is really, I think the question is how do people approach their the ethics that really is behind their project, and what are the ethical issues, and just get people to think about these a bit more. Then all the things about open science that I think we're going to talk about today as well. Experimental design, like I just said. Statistics, I think, is one of those issues that we are probably not teaching very well, and I'm from a generation that used to use SPSS and a very nice point-and-click adventure. But I think these sort of point-and-click adventures are really not reproducible. So think about how we can sort of integrate programming with statistical skills, and I think we need to have better skills in these areas. Again, one of the things that we are not teaching probably as much as we should is sort of critical thinking and peer review. So what are the important parts of a paper, and how do I critically assess a paper? Where do I find the methods section? And I always, when I talk to publishers, I always say the first thing that they can do is put the methods section where it belongs. When you look at Science and Nature, where do you find the methods section? Well, it's somewhere tucked away in the online version, somewhere behind the supplementary materials. And this is ridiculous, right? If you want to critically assess a paper, you want to read the methods section more than anything else. So this is one of the things that we really need to teach people and think about. It's not really about an exciting question. It's not about an exciting result. It's actually about whether or not people use the right methods to answer the question that they were looking at in the first place. And I think it's something we're teaching way too late. I think it's something that people start to understand when they are DPhil students, PhD students, you're called here. But I think this is way too late. When people come from their undergrad, they sort of think that all that's published in the literature is really true. And then they become these, cynical persons like me later on, where they realize, well, it's only like 5 to 10% of the literature that's actually true. So I think, maybe teaching people how to critically review things earlier, I think is really valuable as well. And then, like I said, pre-registration, I think, is one of the issues that we can really teach much more, but also I think really helps to improve the experiments that we do. And so, but like I said, it's not just about it's not just about teaching. We simply started with teaching because this is relatively cheap, and basically only costs our time, and nobody's really going to bother with us. Nobody's really threatened by us teaching these kind of things. But really, I think where it's going to come to crunch time is thinking about all the other things that we need to change. And this starts with incentives. I think if we don't incentivize this sort of right way of doing research, I think things are never going to change. And this is where we need to think about HR policies. And I think this is where it again comes back to the debate of how we're treating early career researchers as well. And do you really think we can do good research on a 1-year or even a 2-year contract? I think this is a slightly ridiculous notion, really, because all the kind of things that I talked about, they will take time. And so we need to think about how we need to adjust our HR policies, really. The second thing about open data and open methods especially is that we need the right infrastructure for these things to happen. And we're having really great discussions with our libraries, for example, and I have no idea whether it's similar here, but the librarians in Oxford are super interested in helping us along this way. And I think we've had really great debates, and we're going to continue that discussion as well. Like I've already mentioned, I think we need to think about research ethics review and what kind of procedures, how we need to change and sort of improve our procedures there. And there's lots of other things, and I'm very happy to talk to anyone about all the other stuff that's happening over coffee later if you want. And so I'm not sure how many people are aware of the UK Reproducibility Network, but that was launched only in September. And it's basically sort of a way to connect the different open science, but also reproducibility working groups. And the great thing about the UKRN is that now they've managed to get funding from basically all the important funders in the UK. And we had all the important funders, well, basically all the research councils around the table at the launch meeting. And I think that was actually amazing to see, because we realized, well, the funders realize they're really, really interested in these topics. So I feel like if we can sort of be ahead of the game as individual researchers, but also as institutions, and sort of show the funders that we're actually going in the right direction, I think they will hopefully not sort of develop solutions that are... I think my point is that as researchers, we want to be at the table when they develop solutions for us. So I think, let's keep the conversation going, and let's not wait until they mandate things, and possibly mandate things that we don't necessarily agree with. So I think it's great to have everyone around the table and just keep talking. So I will stop talking now. I will just say thanks to all the different people in our group, Reproducible Research Oxford, the core people there. I'm also part of the Open Science Working Group at the Wellcome Center for Integrative Neuroimaging, where we're trying out a lot of the ideas that I talked about. Thanks to Chris Chalmers and Markus Müller who are setting up the UK Reproducibility Network. And thanks to the guys in Berlin with whom we are organizing the summer school. Thanks for your attention. And